we have constraints. So basically we're going to draw a shape on the two-dimensional plane, and we have a thing called constraints. So my constraints are the boundaries of the function. So what we have is we have x plus 2y, right, is less than or equal to 5. Then we have another constraint which is x minus y less than or equal to 2. And then we say that x is greater than or equal to 0 and y is greater than or equal to 0. Okay? And so what I'm going to do is I'm going to graph these, and you'll see all these inequalities and a bunch of shading that overlaps. And what we're going to do is we're going to create a shape and enclose something within the shape, and we call that the feasible region. Now, in reality, this happens in the real world all the time for business models. So if I had a company and I made something and I sold something, there are a lot of factors that come into whether or not I'm going to make a profit or not, or how many items I need to make, right? So like, just to kind of give you an example, one equation could represent the cost of the raw materials. Another example could be the cost of labor. The other example could be a function that represents how much of a profit I'll make from one store. And then I also have to consider, well, anyways, you could go on and on and on, and you'll have a bunch of shapes, and then all of those parameters have to fit in what we call a feasible region. So now if I graph this, let's start here. Y equals 0, what does that look like?
The x-axis.
Huh? The x-axis. So what we're going to do, because it includes it, we do a solid line. Now it says greater than 0. So where do I shade? Above or below the line?
Above.
Above. So I'm not going to shade the whole thing. I'm just going to put these little arrows above the line, right? And just leave it like that. Okay? Just going to leave it like that. Now, x is greater than 0. What is x equals 0? How does that look? Yeah, it's the y-axis, so I'm going to do a solid line on the y-axis. Now here we have to use our thinking caps, right? Give me an x value greater than 0. 5, 2, 1, any of those numbers. Where on the x-axis would that be? To the right or to the left? To the right. So I would shade to the right. Now I'm not going to shade the whole thing. I'm just going to make these little arrows as a reminder for Mr. Adams to know. Now already, do you guys know what quadrant we're trapped in? Quadrant 1. Remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So already, our feasible region is trapped in quadrant 1. So now to graph this equation here, I'm going to take, whoops, let me undo that, whoops. All right, I'm going to take this whole equation here, whoops, just this part. Boy, it didn't like that. Let me see this. It's not going to let me do it because it's all there. So anyways, if I take this, x minus y is less than or equal to 2, right? And I solve for y, what I end up with is y is greater than or equal to positive x minus 2, right? So I'm going to subtract x from both sides, put it over there. Then I'm going to divide everything by -1, correct? So I have a slope of +1 and a y-intercept of -2, right? And you know what? I'm going to graph that in green. And so I start here at y equals 2, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. I have an equal sign, so I'm just simply going to draw a solid line through here, but really, I only need to draw it through the first quadrant, right?
Yeah.
And my y value needs to be greater than that, so I'm going to go above the line. Okay? All right, cool. And actually, you know what I think I will do, though, just to make sure that I'm really accurate? I'm actually going to plot, I'm going to be a little more meticulous about this. I'm going to actually go up 1 over 1, up 1 over 1, up 1 over 1, and make sure that my line is pretty accurate. All right? Now, for the last one, if I do the same thing, if I take, let's do this in purple, right? If I take that and I say x plus 2y is less than or equal to 5, I subtract x from both sides. And I get -x plus 5, and then divide by 2, basically. And I'm going to divide everything by 2. Well, then I get y is less than or equal to -1/2 times x plus 5/2. So I have a y-intercept of 2.5 with a negative slope. So I'm going to go up 1, 2, 0.5. This is my y-intercept. And from there, I'm going to come down 1 and over 1, 2. Down 1, right? Going to come down 1 and over 1, 2. And again, that's a solid line, right? And so I'm going to just draw from here to here. And y is less than, so I'm just going to shade here. So now what I'm looking for, the shaded region, is where all 4 of those overlap. And so I'm just going to color that in orange. So I'm going to go here and here, above this, and then below this. And so this right here is what we call the feasible region. And basically, an x and y value from that entire region will give me a solution to all of the constraints. So then the question says, what point in the feasible region maximizes the point P for the objective function P is equal to 2x plus y? So that was the question. I had to label all that stuff and explain all that stuff to you. But the actual question is, which one maximizes this? Well, 2x times y. What they're recommending is it says you can solve using linear programming by testing in the objective function all the vertices of the feasible region. So what I have to do is I have to come in here and look at all these vertices. One of these will probably work. So this vertex here would be 0, 3, right? This one here would be 0, 0. This one over here I think is 2. Is it 2, 0? And this point right here, I don't know if that's 1, 1, or no, 2, 1. 2, wait, I've got 0, 0.
It's 3, 1.
3, 1. So this is 3, 1. Actually, why do I have that going to 3? It's 2.5. not 3. So this one right here is 2.5. 0. This one right here is 0, comma 2.5, I believe. I knew that was a little weird. All right, do I have them all now? Yep. So now, basically, now that I've graphed the constraints, and I go to the vertices, one of those will work. Well, we want a maximum p-value. So what I'm going to do is I would say p is equal to 2 times 0 plus 0. So this is my x value, this is my y value, and I'm plugging that in. That gives me p equals 0, right? So now we're going to do another one. We're going to say p, and if I wanted to be a little more formal, let me be a little more formal. Actually, let me erase this. Let me move this up here. Well, let me just write it out. So if I wanted to be a little more formal, I could say p of 0, comma 0 is equal to 2 times 0 plus 0, which is just 0. And then if I want, I would do the next one. I would say p of 2, comma 0, which would just be 2 times 2 plus 0, which is 4. Then the next one, I would say p of 3, comma 1, which would be 2 times 3 plus 1, which would be 7, right? And then for the next one, I could say p, comma 0, comma 2.5, which would just be 2 times 0 plus 2.5, right? Okay, which is just 2.5, right? Does that make sense? So which one gives you the maximum value? Which point? 3, comma 1. So this is our maximum value for p.